So yesterday we started with this framework, YT is equal to CT plus IT plus GT. The similar type of national income accounting framework as we considered in case of Samuelson's model. The only difference, as I mentioned last day, and you also realized, instead of considering G to be exogenous in the system, here we are considering GT. G is also varying with time. Consumption and income relationship is given by CT is equal to small c into YT minus 1. So there is a lagged response. Consumption of Tth period is a function of income of T minus 1th period. The investment is the difference between the income of previous two periods. Actually, it is the stock of the last period. It's the proportion of the stock of the last period. Okay, so V is the accelerator. Generally, investment will be far higher than the stock the economy has in the last period. So V will generally magnify the system. Okay. However, you know, if you look at the economy of 2020 and 2021 during this COVID days, actually starting from 2000 currency printing, you know, so in that case, V is not magnified at all. We do not know what will be the value of V. Okay, I hope you can expect this V will be very, very small. Okay, so in general, it is assumed that V is the accelerator and will magnify the stock. Investment will be far ahead of the stock. Okay. However, because of changing macroeconomic situation, the value of V will also change. Okay, so we actually plugged equation number 2 and equation number 3 in equation number 1 and framed a second order difference equation in income. Okay, and from that equation you derived the PI part, particular integral part, or equilibrium income, which is given by GT by 1 minus C. So when we are considering equilibrium, when we are considering a steady state, okay, so this will not work, you know, because this is not a PowerPoint. Actually, equilibrium position implies economy is at a steady state. Okay, so accelerator ceases to operate in this case. So whenever we are getting the equilibrium value, we are finding it is a function of MPC, marginal propensity to consume. Okay. However, it is not guided by the accelerator. It is not guided by V. So this is the construct, and this YE value is very, very close to that of the YE value we got in case of Samuelson's model. In fact, it is similar, identical. We got G naught by 1 minus beta. Okay, in Samuelson's model, G was exogenous, therefore we got G naught, and here G is not exogenous, rather dynamic matter, and for that thing, we are getting the value GT2 by 1 minus C. Now, to derive the time part of YT, we will move towards the complementary function part. Okay. However, in case of second order difference equation, as you got in case of Samuelson's model, you need to find out the characteristic equation, and from that characteristic equation, we will derive the roots, and the values of the roots will determine everything. The values of the roots will determine whether the economy will be stable or not, the equilibrium will be convergent or not, or time path over time will move towards equilibrium or not. And again, the B values will determine whether the time path will be monotonic or whether the time path will be oscillatory. Briefly, if we find the absolute value of the two roots, these are less than 1, in that case, you will have convergent time path of income. Otherwise, you will have divergent time path of income. On the other hand, if the roots are real distinct or real repeated, in that case, you will have monotonic time path. Otherwise, that is, if the roots are imaginary or complex conjugates, in that case, you will get oscillatory time path. Okay, so this is the basic framework. Now, I got the question, or the query, why we are not solving capital A and capital B as we solve in case of the first order difference equation. Actually, in case of the first order difference equation, the entire calculation is simpler compared to this thing, and we do not need to talk about the characteristic equation, characteristic roots, etc. So the format is, or the solution pattern is little bit different from that of this one. In that case, we derive the values of capital A. Here, you can derive the values of A and B using the initial conditions. However, the calculation is not that easy because the structure is a different structure. So what we consider, there is a starting point that we are understanding. There is a starting point, why not will be there. There will be a point when t is equal to 0 from where we are actually starting the time path. However, in general, we do not solve for A and B. I think Oyon sent me the question.
Yes, ma'am.
Okay. When we will go for differential equation, you will find that how we are bringing these A, B, C, D. In terms of the calculus, it will be a bit easier to understand the matter. As a technique, you will find that we are trying to find out A, B using the sine theta, cos theta, this kind of thing. So geometric matter will come when we will move for differential equation. For the difference equation framework, we understand we should have a starting point, and these A and B will determine what will be the starting points. However, if you go through the text, you will find that we are not solving for A and B. Okay? Because focus is on roots of the thing. Here, the focus will be on the roots. Roots will determine characteristic equation, and thereby characteristic roots will determine what will be the basic structure of the time path. Okay, so entire focus will be on that part. Okay, so thank you. We are starting the discussion which we should do after deriving the equilibrium income. So as you know from the Samuelson's model, here we will go for hat operation. Okay. So for hat operation, basically we will consider the difference of yt from the equilibrium. So in this way, we are taking the difference of all yt's, yt minus 1, yt minus 2 from ye. Ye is a fixed value. So from that, we are taking the deviation. So for deviation from the equilibrium, we subtract 6 from 5. So let's see what is 6. 6 is ye. Rather, it will be better to say, we actually take difference of this from this. Okay? We take difference of this from this equation number 5. Okay? So yt minus ye minus c plus v yt minus 1 minus ye plus v yt minus 2 minus ye, and in the right hand side 0. Okay, so this will be the equation yt minus ye, etc. Then we are doing a hat operation considering yt minus ye to be yt hat. Yt minus 1 minus ye is yt minus 1 hat, and yt minus 2 minus ye is yt minus 2 hat. So this is the required equation number 7. So this is a second order homogeneous difference equation in yt hat. Okay, so I hope everybody will agree this is the homogeneous form of the equation. This is the homogeneous form of the equation, because in the right hand side we do not have any constant term. It is equal to 0. So for a solution to 7, for a solution to this equation number 7, or the homogeneous form, we try yt hat is equal to b to the power t, where b is any arbitrary constant. So equation 7 can be rewritten as, in place of yt hat, b to the power t, in place of yt minus 1 hat, b to the power t minus 1, and in place of yt minus 2 hat, we are getting b to the power t minus 2. So this is equation number 8. This is equation number 8. So what we are doing? First, we are considering hat operation, and then to find the solution of the homogeneous form, we consider a trial solution for yt hat, which is yt hat is equal to b to the power t. And we frame equation number 8. Once we get equation number 8, without losing any generality, we can set t is equal to 2. And if we set t is equal to 2, we get a quadratic equation, b squared minus c plus v into b to the power 1, t minus 1, so 2 minus 1, so b plus v, because b to the power 0, the last term will be b to the power 0, which is equal to 1. So this is the required quadratic equation, which we need to frame in context of a second order difference equation. Are the steps all right to all of you? Any question? I hope you are doing the things with me.
Yes, ma'am.
At least the equations. You don't need to write every point, you know. Whenever I'll tell you something new, or whenever you need to take some note, you can take that. However, it's always best to write down the equations. If it is an offline class, you know, so we request all of you to do these things. So this time too, I am requesting all of you to do these things, because there may be some mistake in sign, there may be some mistake in calculation. So always there is this kind of thing. So once we get equation number 9, and if you have no problem with equation number 9, what will be the next step?
We will find the roots.
We will find the roots. Okay, b1 and b2. Okay, and what will be the general formula to derive b1 and b2? What is the formula?
Minus b plus minus root under b square minus 4ac by 2a.
Okay, yeah, very good. So the formula will be minus b plus minus root over b square minus 4ac by 2a. So, you know, please write down. So from equation number 9, we get, actually the equation number 9 is the characteristic equation, okay? Equation number 9 is the characteristic equation for equation number 8. So solving these characteristic equations, we get two roots, b1 comma b2 equal to, please write down the value. So here minus b means minus of c plus v, which is simply c plus v. Then plus minus root over b square, that means c plus v whole square. Now what is the value of 4ac?
4b.
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 So are we getting this one?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Hope everybody got this one. So these are the two roots, v1, v2, c plus v by 2 plus minus root over c plus v whole square minus 4v by 2. Actually, you can write 2a. However, I'm splitting it into two parts, because roots may be real distinct, roots may be, a real repeated. In case of repeated real roots, the value will be only c plus v by 2. Okay. Or if the discriminant is negative, in that case, that is 4v is greater than c plus v whole square, in that case we will get the complex roots. Okay. Now from equation number 9, apart from values of the two roots, we get b1 plus b2. What is the value for b1 plus b2? Standard formula?
Minus b by
Minus
a.
b by
Minus B by
Okay, minus b by. So here the value will be c plus v then. Okay, and as
Yes, ma'am.
I'll bring MPS in the analysis. Okay, so I'm replacing small c by 1 minus small s, where small s is MPS, marginal propensity to save. Okay, so b1 plus b2 is also 1 minus s plus v. And we have to talk about product of two roots, b1 into b2. So what is the general formula for product of
c by
C by
a.
A.
C by A.
c by a? C is
V.
yeah. So v by 1, v. Next, if the roots are real, it follows that b1 and b2 are each positive number. Okay. Look at b1 plus b2. b1 plus b2 is positive. Small s is less than 1. It lies in between 0 and 1. So 1 minus s is positive. V is accelerator, always positive. Okay. So b1 plus b2 positive, b1 into b2 is positive. That tells us both b1 and b2 are positive. Here b1 into b2 is only the accelerator, v. Are you getting any difference with the Samuelson's model when you are considering the product of b1 and b2? Can anybody remember what was the product of two roots in case of Samuelson's model?
Alpha beta.
Alpha beta. Okay, so in case of Samuelson's model, the product of two roots are determined by the interaction of multiplier and accelerator. However, in the Higgs version, the product of two roots are determined by V only, the accelerator. It is determined, equilibrium is determined only by the multiplier, or you can say MPC. However, here what we are getting, B1 into B2, that is simply the accelerator of the model. So we are not getting interaction between multiplier and accelerator while we are considering the product of two roots. Okay, so this is the difference. Okay, so later when we will use the stationarity condition, maybe Actually, if you can remember, the stationarity condition was determined by the product of these two roots, alpha beta less than 1. That was the stationarity condition. So here there is a chance that stationarity condition will be determined only by V, only by accelerator. So keep this point in your mind. Let's see what is happening in case of Higgs-Samuelson framework. So if the roots are real, it follows that B1 and B2 are each positive number. Is it clear to everyone, or should I need to clarify why the two roots will be positive? If the roots are real, why two roots will be positive? Is it clear to everybody? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes.
If anybody has any confusion, please tell, we can discuss the matter, no problem.
Ma'am, could you discuss it once more?
Why the two roots are positive?
Ma'am, I understood that B1 plus B2 and B1 into B2 are positive. That I understood. So individually, why the roots are positive? Yes, ma'am, I want to know that.
Okay, Prithviraj, would you tell us?
Ma'am, I am having the same query.
Okay, you have the same query. Is there anyone? Upanita told us that she is understanding. Upanita, would you please explain? Yesterday I explained the matter. So can you explain it?
Ma'am, I asked the question only.
Okay. So B1 and B2, if you look at the product part, B1 and B2 should have same sign if I want the right hand side to be positive. Okay. So if I look at the product, we can tell that either both of the roots will be negative or both of the roots will be positive. Okay. So first,
Yes.
that thing, B1 into B2 is equal to V, which is positive. This indicates B1 and B2 should have similar signs. Either both of them will be negative or both of them will be positive. Okay. Now we are coming to the plus part, B1 plus B2. Now B1 plus B2 is positive, 1 minus S, that is positive, V is positive. So please write down B1 plus B2, that is greater than 0.
Yes,
Okay.
ma'am.
Now if both B1 and B2 are negative, in that case it will be negative.
Yes, ma'am.
So the only way out is both of them.
Both are positive. Okay. Okay. Yes, ma'am. Thank you so much.
So rest of the students, are you getting the point?
Yes, ma'am.
What
Yes, ma'am.
product is telling you signs will be similar. So either both of them negative or both of them positive. Now you are looking at the sum of the roots. Sum of the roots is positive here. Right hand side is positive. So the only possibility is both of them are positive. Okay. So this is one part. So we are understanding both the roots will be positive. So if the roots are real, it follows that B1, B2 are each positive number. Further, we consider 1 minus B1 into 1 minus B2. So I am solving for 1 minus B1 into 1 minus B2. It is 1 minus within bracket B1 plus B2 plus B1 into B2. So I am plugging the values for B1 plus B2 and B1 into B2. As I do so and adjust the elements, I am getting it is simply MPS, S, small s. And if it is small s, it is positive. So please check the steps. If anyone have any question, any query, please ask me. So please check the next sentence.
Ma'am, I couldn't understand the accelerator multiplier part. Excuse me, ma'am. Ma'am, I couldn't understand the accelerator multiplier part. How do we know that alpha beta is accelerator into multiplier and V is only multiplier?
I'm taking the question within a minute.
Okay, ma'am. Thank you.
Ma'am, can you please explain why x is coming greater than 0? 1.
Yeah, what, please let me know what are the questions one by one.
Ma'am, I couldn't understand the accelerator multiplier part. How do we know that alpha beta was accelerated into multiplier and here V only indicates multiplier?
And what is the last question? Please, a bit louder.
How do we know that alpha beta was in the previous model accelerated into multiplier and here V is the only multiplier? How do we know
You didn't
which?
you check the earlier thing? Didn't you check
Yes,
the
ma'am.
sequence model which we discussed earlier?
Yes, yes, ma'am. There, how do we know that alpha into beta is accelerated into multiplier? I know it's alpha beta.
Alpha into beta is not accelerator. That is accelerator multiplied with multiplier. Okay. So in the Samuelson's framework, B1 into B2, that is alpha into beta. Look at the thing. In case of Samuelson's model, B1 into B2 is alpha into beta. So Anandarupa, are you getting this? So it is accelerator multiplied with the multiplier, alpha into beta.
Yes, ma'am. Yes, ma'am.
And in case of heat Samuelson model,
Ma'am,
Okay, so I hope, the first question was why I talked about interaction between alpha and beta, why I'm considering the product of two roots. Okay. Yes.
Yes, ma'am. Yes, ma'am.
Okay. So,
Ma'am, yeah.
let me first finish. So, in case of the Samuelson's model, while we define B1 into B2, that is alpha into beta. So, if alpha magnifies something and if there is beta, beta may reduce the impact of accelerator. Or if beta is very small, in that case, if alpha is very high, in that case, there will be some adjustment between the thing. So alpha may take a very high value. However, if beta is very small, in that case, their interaction will generate a moderate value for B1 into B2. On the other hand, if both the values, if multiplier is takes the high value, or rather beta takes the high value, not the multiplier, beta is the MPC itself. So if MPC takes a high value, alpha takes a high value, then their product will be very high. So all these things are there. So interaction between the multiplier and the accelerator, that determines what will be the nature of B1 into B2. Actually, we are emphasizing or focusing on this point. As we found from the Samuelson's model, actually the product B1 into B2, that ultimately defines the stability condition. The stability condition is determined by mod B1 less than 1, mod B2 less than 1, and therefore their product should be less than 1, and their product is B1 into B2. Okay, so ultimately the stationarity condition or the stability condition was determined by the product B1 into B2. So maybe here the similar thing will happen. Therefore, we are focusing on the product B1 into B2. Okay. So if the stability or the stationarity condition is ultimately determined by the product B1 into B2, in that case, accelerator will take a major role to determine whether the time path is moving towards equilibrium or not. Okay, this was a bit different in the Samuelson's model, because in that case, the interaction between beta and alpha, that determined the stationarity. Here maybe only accelerator will determine what will be the nature of the time path in terms of convergence and divergence. So that is the first thing to clear. Next question. Next question.
No, ma'am, it is clear. Thank you, ma'am. Thank you, ma'am.
Okay. Some people, student had another question. Do anyone have any question?
Ma'am, the multiplier decides the final equilibrium point and the work of accelerator is only to?
Would you please repeat your question?
Ma'am, I am saying that the multiplier decides the final equilibrium point. So what is the work of the accelerator?
Point means final means?
Final means the intertemporal state, the equilibrium, the steady state.
There is no final thing. There is only one. It's not that there is YE1, YE2, and then YE final. So there is nothing like that. Intertemporal, when we consider the intertemporal equilibrium, the accelerator ceases to operate. In a steady state stage, something which will accelerate naturally, that will not be operative. Okay. So steady state or the equilibrium is determined only by the multiplier. So the same thing happened to Samuelson's model as well as the Higgs-Samuelson model. Okay. However, when I am proceeding and getting the product of two roots B1 and B2, in case of Samuelson's model, I get this to be equal to alpha into beta, whereas in the Higgs framework, I am getting this to be equal to V. And then I am trying to, understand, so what can be the stationarity condition here, and what will be the role played by accelerator and beta in context of Higgs model. In case of Higgs-Samuelson, since B1 into B2 was alpha beta, we are understanding the convergency or stationarity condition will be determined together by alpha and beta. Here we are getting only one factor, accelerator, MPC or the multiplier, all these things are not coming here. Okay?
Yes, ma'am.
Okay, so we came up to this 1 minus B1 into 1 minus B2, that is MPS, that is positive. Now, when this product is greater than 0, this implies B1, B2 each less than 1. Okay, look at the equation 1 minus B1, 1 minus B2. Now, if any one of them is negative, either 1 minus B1 or 1 minus B2 negative, in that case, it cannot be positive.
Yes, ma'am.
So 1 minus B1 into 1 minus B2, this is simply S, and that is positive. This implies B1, B2 each can be less than 1, then also it is positive, or B1, B2 each greater than 1, then also it is positive. Everybody?
Yes, ma'am.
Yes.
Yes, ma'am.
Positive, negative. Okay, both of them positive, both of them negative. Okay, so B1, B2 each less than 1, it is one possibility. B1, B2 each greater than 1, it is another possibility. So from the product 1 minus B1 into 1 minus B2, we are getting this value to be equal to S, which is positive. This implies either B1 and B2 both are less than 1 or both of them are greater than 1. Okay, so these are the points first we are taking care of. Next, we are moving towards the general solution. The general solution in two arbitrary constants is given by yt hat is equal to a b1 to the power t plus b b2 to the power t, where a and b are two arbitrary constants. Now yt hat is equal to yt minus ye, so we can write, or we can keep yt in the left hand side, in the right hand side we will bring ye, so the time path or the structure of the time path is given by yt is equal to a b1 to the power t plus b b2 to the power t plus ye. This is the structure of the time path of yt. If yt tends to ye, as t tends to infinity, the time path of income will be stable. You know all these things? And this is possible if and only if both mod B1 and mod B2 are less than 1.
Yes, ma'am.
Do I need to explain this once again, or you understand this matter? When both of the modulus value of the roots will be less than 1, only then yt will move towards ye as t tends to infinity. Is it understandable? Any question, any query?
No, ma'am.
Ma'am, it is understandable.
No, ma'am.
Okay. Now, since B1 and B2 are either greater than 1 or less than 1, as we got either greater than 1 or less than 1, equilibrium is stable if each of B1 and B2 are less than 1. That is, their product B1 into B2, which is equal to V, is less than 1. On the other hand, equilibrium is unstable if B1 into B2 is equal to V is greater than 1. So look at the matter and tell me whether you are understanding both the points. You are understanding the stability condition. In case of real roots,
Ma'am, can you explain this?
which part?
Ma'am, when equilibrium is stable and when it is unstable.
Are you understanding this part? Yt tends to ye as t tends to infinity as time.
Yes.
But and then the second sentence, this is possible when mod B1 less than 1, mod B2 less than 1. This is understandable.
Yes, ma'am, I understand these two sentences.
You are understanding this part.
Yes.
Okay. So you are understanding that absolute values of B1 and B2 should be less than 1. Okay. Now for B1 and B2, there are two possibilities. Either they can be less than 1 or they can be greater than 1 from your earlier calculation. Either both of them can be less than 1 or both of them can be greater than 1. Okay?
Yes, ma'am.
So, to have the stability, you will consider B1 into B2, which is equal to V. Okay? So, if either they can be greater than 1 or less than 1, only when they are less than 1, you can establish the conditions mod of them are less than 1.
Yes.
Okay. So if mod of them, both of the absolute values are less than 1 for any variable, both of the absolute values are less than 1, say 1/3 and 1/5. In that case, what happens to their product? Is it less than 1 or greater than 1?
Less than 1.
So here I am writing the same thing. There are two possibilities. For stationarity, we need absolute values should be less than 1. However, for B1 and B2, there are two possibilities. Either both of the values will be greater than 1 or both of the values will be less than 1. So here we will go for both of the values less than 1 then. Now, if both of them are less than 1, their product will be also less than 1. Now we get the product of them is nothing but V. So the stationarity requirement for the time path of Yt is V should be less than 1. Accelerator should be less than 1. On the other hand, equilibrium will be unstable if their product, that is V, is greater than 1. So now you are understanding?
Yes, ma'am. Ma'am, I had another query, which was that is there any difference between the equilibrium condition or the stationary condition, or are the terms interchangeable? Like they're the same thing.
Equilibrium condition or equilibrium income means YE. Okay. And stationarity or stability, this indicates whether YT is moving towards YE or not. Dynamic stable equilibrium or dynamically convergent equilibrium, that means time path moves towards the equilibrium value YE. Okay, so equilibrium is one concept, stability of equilibrium is another concept, or stationarity of the equilibrium is another concept. Okay,
Okay,
stationarity,
ma'am.
stability, convergence, divergence, these are related to the time path yt. Whether yt is moving towards that fixed value ye or it is not moving. Ye is a fixed value. Okay.
Yes, ma'am. Thank you.
So far, so I hope everybody understood the stationarity or the stability indicates B1 into B2, which is equal to V less than 1 in this case. Next, I have to consider the condition when the roots are complex conjugates. We have considered the case when the roots are real. Next, we need to consider when the roots are complex conjugates. So if the roots are complex conjugates, we consider the absolute value R. That is equal to root over V, where V is the absolute coefficient of yt minus 2. The same thing which we discussed last day. Okay. So this thing or this thing, the coefficient associated with b to the power t minus 2 or y t minus 2 hat. This coefficient, I have to consider the square root of the coefficient associated with yt minus 2 or yt minus 2 hat or b to the power t minus 2. So this thing. R can be greater than, equal to, or less than 1. Okay. Theoretically, R can be greater than, equal to, or less than 1. Among these possibilities, time path will be stable if and only if R is less than 1. So if the roots are complex conjugates, then too the stationarity or the stability requirement is V is less than 1. So roots may be real, roots may be complex. However, the stationarity or the stability or the convergence requirement is V is less than 1. V is less than 1. Next, to understand whether the time path is monotonic or whether the time path is oscillatory, we consider the discriminant of the quadratic equation 9. So just quickly, let us check the discriminant. Okay. So what is the discriminant?
C plus V whole square minus 4V.
C plus V whole square minus 4V. I'm considering this entire part. Okay. So discriminant is, can we write the thing in this way?
Yes, ma'am.
So please write down and then write down that value and check it, please. Please write down delta is equal to C plus V by 2 whole square minus V. And here, please have a rough work.
Ma'am, can you explain why did you consider the whole value? Usually discriminant is only the b square minus 4ac part.
There is no harm if you consider 1 by 2 because this will not change the context. Okay. In case of Higgs framework, while he is explaining the model, he considered the entire part. This entire part was considered, and following that principle, I am doing so. Okay.
Okay, ma'am.
Ma'am, so we are considering this form for convenience.
C plus V whole square, C plus V by 2 whole square minus V.
Yes, ma'am. I mean, why can't we just take the normal discriminant form?
Yeah, this is the standard thing, because, there is some adjustment, and Higgs presented the entire thing in terms of whole square, etc. And following Higgs only, we are doing so. If I keep the standard part, he is keeping the first part separate and considering the entire second part, while moving towards the analysis of whether the time path will be monotonic or the time path will be, oscillatory in nature. And actually, this denominator will not change any way the entire part, and therefore there is no harm. Without losing any generality, we can do so.
Okay, ma'am.
Okay, and is there any problem regarding C plus V by 2 whole square minus V format? Please check. So I hope it's fine to everyone.
Yes, ma'am.
Yes, ma'am.
Okay. Now roots are real. As you know, if this part is positive, if this entire part is positive, then the roots are real. And this can be presented as C plus V by 2 greater than root V. And then actually I'm trying to bring one whole square format. So C plus V greater than 2 root V. Okay. And then 1 minus 2 root V plus V greater than 1 minus C. Is it okay? So I am bringing one both at the left hand side and in the right hand side.
Yes, ma'am.
V is there, minus 2 root V is there, C is there, so I'm bringing here, so minus C. Adding 1 here, adding 1 here. So I'm bringing 1, 1 both in the left hand and the right hand side, everyone.
Yes, ma'am.
Do so. The left hand side can be written as root V minus 1 whole square, or it can be written as 1 minus root V whole square. Both the things. Root V minus 1 whole square or 1 minus root V whole square. Left hand side. Right hand side is S. 1 minus MPC is MPS. So please check whether this is fine to all of you. The left hand side can be either presented by root V minus 1 whole square, or it can be presented by 1 minus root V whole square. So I hope it's fine to all of you.
Yes, ma'am.
Yes, ma'am.
Okay. Next. First I am considering root V minus 1 whole square greater than S. Okay. Actually, I want to bring V in at the left and rest of the things like this. Okay. So for the presentation purpose, one by one, I'll consider root V minus 1 whole square greater than S, and then 1 minus root V whole square greater than S. So if I consider root v minus 1 whole square greater than s, we get root v minus 1 greater than root s. And from there, please check whether we are getting v greater than 1 plus root s whole square greater than 1. Please do the steps, and if anyone have any question, please ask me regarding equation number 10. Next, please do the steps for this equation 1 minus root v whole square greater than s, and please check whether you are getting this. So please complete the steps for this. Once you complete, I'll request any one of you to present the thing. So please do it, check whether you are getting this value or not. Please do it.
Ma'am, we just need to show how we got number 11, like that last form, equation 11.
Anyone would
Yes,
like
ma'am,
to?
done.
Okay, so I'm closing my presentation. Please show the steps. Show water. আর একটু ফোকাস করবে প্লিজ।
Ma'am, now it's clear?
দেখো সবাইকে দেখতে পাচ্ছ? Is
Yes,
it
ma'am.
visible to everyone?
Yes, ma'am. More or less it's clear.
More or less clear. Yeah, the writing is clear. However, it's so small in my computer. I am not getting it properly. However, please check if you understand the matter.
Yes, ma'am. It's the same.
Yes, ma'am, we got.
Yes, ma'am. We got it.
Yeah, somebody had some question regarding the steps. Somebody asked, I think. So everybody is happy, got the relation?
Yes, ma'am.
Yes,
Okay,
ma'am.
sure. Thank you.
Thank you, ma'am.
Very good. Okay, so 10 and 11 are there. Okay, so please look at the statement. For V less than 1 minus root s whole square less than 1, B1 and B2 each less than 1, which implies yt tends to ye as t tends to infinity, and hence we get monotonic convergent time path of yt. On the other hand, for equation number 10, v is greater than 1 plus root s whole square greater than 1. So, if you look at this v and this less than 1, you are getting the thing, So, when v is greater than 1 plus root s whole square, it is greater than 1. This has been established by 10. When 1 minus root v whole square is greater than s, then v is less than 1. It has been established by equation 11. So by 10, it has been established v is greater than 1. By 11, it has been established v is less than 1. Now, what is the condition required for convergence of the time path? V should be less than 1. Okay. So, equation number 11 gives you monotonic convergent time path. And if this is the situation, in that case, you get the monotonic divergent time path. Why I am talking about monotonic? Because both the cases belong to the real root case. So when the roots are real, we get the monotonic time path. In case of equation 10, it has been established v is greater than 1. In case of 11, it has been established v is less than 1. So when v is less than 1, you will get monotonic convergent time path. And in this case, you will get the monotonic divergent time path. Is it clear?
Ma'am, so basically we are again considering two cases where each of B1 and B2 are less than 1 and another one in which each of B1 and B2 are greater than 1. Okay, okay.
Okay, in terms of the parameters of the model, that is MPS and V, we are presenting the situation. Actually, as we did in the last class, we have to go for graphical analysis. We have to identify, what is the zone where you can have monotonic convergent, monotonic divergent, oscillatory damped, oscillatory explosive kind of time paths. Okay, so we are understanding this thing, in terms of trying to understand the matters in terms of the accelerator and the MPS in case of the Higgs framework. Okay. Next, roots are complex conjugates if this part c plus v by 2 whole square minus v is less than 0. Okay. So from there, c plus v by 2 less than root v, or c plus v less than 2 root v, similar kind of calculation I am doing. Adding 1, 1 both sides. So 1 minus 2 root v plus v less than 1 minus c. So either root v minus 1 whole square or 1 minus root v whole square is less than s. So let's first consider root v minus 1 whole square less than s. And please check whether you are getting this kind of condition from there. Any question regarding this first part?
Ma'am, may I ask something? I have a small
Yeah.
doubt.
Yeah.
Yeah. Ma'am, I understood here why V is greater than
V is?
root s whole square. I couldn't understand how we can write in equation 10 that v is greater than 1 plus root s whole square greater than 1. Where did we get the other greater than 1? It could have been less than 1 in 10.
This one. This you didn't understand.
And even in 11, how do we know?
How 1 plus root s whole square is greater than 1? This you didn't understand.
Yes, ma'am. How?
S is the
I
MPS.
understood.
S is the MPS, marginal propensity to save. Now, what is the possible range for S?
0 to 1.
So, what is the possible range for root S?
0 to 1.
Okay, if something is added with 1, that will be positive, or sorry, that will be greater than 1. I hope you understand.
Yes, ma'am. Yes, ma'am.
And if you take square of that, you are adding something with 1, say 1.2, 1.1, 1.5, 1.9. Okay?
Yes,
And if
ma'am.
you take square of that, will it be greater than 1 or not?
It will be, ma'am.
It will be greater than 1. Okay?
Okay.
Next,
Yes.
root S. Root S is again lie between 0 and 1,
0 and
greater
1.
than
Yes.
less than 1. So if you subtract something from 1, it can be 0.8, 0.9, whatever.
Yes, ma'am. Yes, ma'am.
Okay. And if you take square of that, will it be less than 1 or greater than 1?
Less than 1.
So now you are understanding?
Yes, ma'am. Thank you, ma'am.
Okay. For the complex conjugate part, I hope this first part is clear to all of you. The similar thing we did earlier.
Yes, ma'am.
Okay, the similar thing we did here, only here greater than, and in that case less than. So similar kind of thing we did there. So if this is clear, first I am considering root v minus 1 whole square less than s. Please check whether we can write this, or from there equation number 12. So if anyone have any question regarding this, how we are getting equation number 12, please ask. Is it okay to everyone? Equation number 12.
Yes, ma'am.
Yes, ma'am.
The right hand side is positive here while you are taking the root, because MPS will lie in between 0 and 1 by the macro concept. So I should not write plus minus, okay? It is always positive because it is MPS. So equation number 12 is understandable, and then you check the other one, 1 minus root v whole square less than s. And please check whether you are getting equation number 13 out of that.
Yes, ma'am. Got it.
Okay. So from 12 and 13, so combining 12 and 13, if you look at 12, v is less than 1 plus root s whole square. And if you look at 13, v is greater than 1 minus root s whole square. So v is actually greater than 1 minus root s whole square. However, it is less than 1 plus root s whole square. So please write down this. So combining 12 and 13, we get v should lie in between 1 minus root s whole square and 1 plus root s whole square. Okay. Then I am bringing 1 in between. So I'm making it 1 minus root s whole square less than v less than 1 less than 1 plus root s whole square. Okay, so the equation is 1 minus root s whole square less than v less than 1 plus root s whole square. This value is greater than 1, that we are understanding, isn't it?
Yes, ma'am.
1 plus
Yes.
root s whole square is greater than, just,
Yes, ma'am.
yeah. So please check from this whether we can write, please write down. From this we can also write 1 minus root s whole square less than v less than 1, simply 1, less than 1 plus root s whole square. So can we write this in that way?
Yes, ma'am.
So if I get this, you know, v is less than 1 here. In this case, we can take only that part. So when 1 minus root s whole square less than v less than 1, v is less than 1, in that case, we will get damped oscillations. When the roots are complex, we will get oscillatory time path. And if v value is less than 1, in that case, we will get damped oscillation. Next, another possibility is please write down 1 minus root s whole square less than 1 less than v less than 1 plus root s whole square. Another possibility is 1 minus root s whole square less than 1 1 minus root s whole square is always less than 1. Less than v. So v can be greater than 1. V can be less than 1. V can be greater than 1. Less than 1 plus root s whole square. Okay. Here, one is less than v less than 1 plus root s whole square. From the second criterion, 1 is less than v less than 1 plus root s whole square. And we get explosive oscillations. And we get explosive oscillations. So actually, these range I am writing in 2 different ways. I am repeating. One possibility is 1 minus root s whole square less than 1 less than v less than 1 plus root s whole square. Second possibility is 1 minus root s whole square less than 1 less than V less than 1 plus root S whole square. So in the first possibility, first I am writing V, then I am bringing 1. In the second possibility, first I am writing 1, then I am bringing V. Because V can be greater than 1, V can be less than 1. Okay. And when I'll draw the curve, V can be equal to 1, 2. So in that case, we will get something which is a uniform oscillation. So please tell me whether you are understanding these two things. When we will have damped oscillations, when we will have explosive oscillations. Is it clear?
Yes, ma'am.
Yes, ma'am.
Anyone has any problem? Could you write the range properly? So once you understand the conditions, next, for demarking the regions containing stable and unstable values of V and S in the VS plane. In that case, we consider the alpha beta plane. Here we will consider VS plane. So for demarking the regions containing stable and unstable values of V and S, in VS plane, we first set V is equal to 1 minus root S whole square. So you have to consider V is equal to 1 minus root S whole square. You have to set V is equal to 1 plus root S whole square. And you need to check what will be the shape of V equal to this, V equal to that, you know. We will consider the first order condition, we will consider the second order condition, etc. And we will find that this will be a negatively sloped convex curve, this will be a positively sloped concave curve. So all these things will happen. So one by one, please do these things on your own and please check whether you are getting the similar result or not. There may be some mistake, you know, while I am calculating these things. So please check whether you are getting the same or not. You can do on your own way. It's not that you have to follow everything like this. Ultimately, check the results, whether the results are same or not. Could you complete?
Yes, ma'am.
Getting the same result?
Yes,
Yes,
ma'am.
ma'am.
Okay, so in that case, we can argue that V is equal to 1 minus root S whole square is a negatively sloped convex curve. For the second part, please do on your own. Consider the equation V is equal to 1 plus root S whole square. Got the first derivative, dvds?
Yes, ma'am.
Yes, ma'am.
1 plus 1 by root s, so it is positive. Second order is negative. So it is a positively sloped concave curve.
Yes, ma'am.
Okay. Everybody could complete up to this?
Yes, ma'am.
Yes, ma'am.
Okay. So once we complete this thing, graphically we will present the position. Okay, so here there is no chance that the two lines will intersect each other. All these things are not coming like the earlier one. So I'll mark only the position when v is equal to 1. Along the vertical axis, we are measuring v. And along this axis, I'm measuring s. So I'm getting one curve like this and another like this. Hold on. Okay. This one is v equal to and this one is so please check convexity, concavity, etc. Positively sloped, negatively sloped. Is there any problem, any difficulties?
No, ma'am.
No, ma'am.
So I'm considering 4 zones. Okay. A, B, C, D. What about A? A will contain the stable values or unstable values?
Stable values.
B is less than 1
Stable.
minus square. So it is less than 1. Yeah. So zone A will contain the stable values. And what about B?
Unstable.
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 Unstable values. Okay. So A stable values, B unstable values. Now what about C?
Stable.
Stable. Yeah, because V is less than 1. V is 1 along these horizontal line. V is still less than 1. So stable. And what about D?
Unstable.
Unstable values. Okay, so we are understanding if V is less than 1, that is below the horizontal line when V is equal to 1, the time path will be stable, and above it, time path will be unstable. V greater than 1, V greater than equal to 1 is instability. Okay, the stability condition is V less than 1, strictly less than 1. Okay, so now can you identify where we will have the monotonic time path and where we will have the oscillatory time path? Zone A. Zone.
Monotonic.
Anyone, please?
I was saying that zone A is monotonic.
Oscillatory.
Zone A oscillatory.
No, when V is greater than 1, then we have monotonic, right?
No, monotonic and oscillatory is not related to V greater than 1, less than 1. Look at the condition. Monotonic and oscillatory depends on other things, whether the roots are real, whether the
Real or yes, yes.
Ma'am,
Ma'am, zone A will be monotonic.
it will be oscillatory.
monotonic. The student who is thinking that zone A monotonic, why you think so?
Because ma'am, V is less than 1 minus root S whole square.
Okay, so let me check. So when V is less than 1 minus root S whole square, the time path was monotonic or not?
Yes, ma'am.
No, when B is greater than 1 plus root S whole square, then it's monotonic.
Just let me check. So can you identify whether it will be monotonic or oscillatory? What is happening here? V is less than 1 minus root S whole square. In zone A, V is less than 1 minus root S whole square.
Therefore, monotonic.
Monotonic then? Okay.
Yes,
Condition
ma'am.
you are getting monotonic.
Yes, ma'am. Yes, ma'am.
Okay. So in zone A, monotonic. And another condition of monotonic time path, can you identify from these lines?
Convergent.
This one was convergent,
This one.
the one we just discussed.
And another possibility when it can be monotonic?
Ma'am, V greater than
V
1
greater
plus
than
root
1
S whole
plus root
square.
S whole square.
Yeah, V greater than 1 plus root S whole square. So in zones A and B, in zone A, V is less than 1 minus root S whole square. Okay. So if I shed the zones, in zone A, V is in zone A also monotonic. Zone B Zone B so this is also a condition of monotonic time path. Now here in zone A, along with V less than 1 minus root S whole square, we are getting this to be less than 1. So monotonic, convergent. Here we are getting the value to be greater than 1. So it is. Check whether you are understanding. A, B zones are clear or not. Is it clear to everyone? Zone A and B?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So let's consider zone C. Okay, so in zone C, what will happen? What will be the structure?
It is damped
Oscillatory
oscillatory.
convergent.
Damped oscillations.
The mouse is disturbed. So you are getting here. So what is happening? V is greater than so this is the condition. V is greater than 1 minus root S whole square. Okay, so this is the thing. However, V is less than 1. Damped oscillatory time path. And finally, zone D. Naturally, it will be, explosive oscillatory. However, please look at the condition. Please check everything. This is D. In case of D, so there is one extra root. V is greater than. So, V is less than 1 plus root s whole square. However, and finally, V can lie on 1 on the horizontal line. V can be equal to 1. So in that case, what will be the time path? What will be the nature?
Ma'am, uniform oscillator.
Uniform oscillator.
Uniform oscillator. Will be uniform oscillatory time path. Okay. So these are the possibilities, and now I hope you will be able to draw the relevant time path of income. Already we did all these things, how it will look like, etc. So I hope you will be able to do all these things. So you have to add all the varieties here.
Yes, ma'am.
So complete this part. Okay, so any question, anything regarding the diagrammatic presentation, dividing the zone, how we are getting monotonic time path in several zones, how we are getting oscillatory time path in other zones. Any question, any query, please ask me. Anyone, any question? Take a note. Note. In Samuelson's model, the stability condition is given by, in Samuelson's model, the stability condition is given by alpha into beta less than 1. Here, the high value of the acceleration coefficient, here the high value of the acceleration coefficient, does not necessarily destabilize the time path. On the other hand, in Higgs framework, the stability condition is given by V less than 1. V less than 1. And hence, the high value of the accelerator may destabilize the time path. Okay. So in the Samuelson model, alpha may be very high, but beta may adjust this. So if the alpha value is high, not necessarily you will get divergence. Okay, a beta may modify the value alpha into beta. However, in the Higgs-Samuelson framework, high value of V will necessarily destabilize the situation, okay? Because for stationarity stability, you need V less than 1. So this is all about the framework. So please check all these things. Try to grasp all these things, okay? And I'll mail you if you need to cover some other part from the text. Okay, so please first check all these things, practice all these things. Okay, and we will come back on next Monday. Next class will be on Monday.
Ma'am, can you tell us like what portions, like some of the text we will do? All the exercises.